Okay, so this video is the follow-up to the chain rule video, and is going to be the examples portion of the video on the chain rule. So we finished with I guess expressing the chain rule in a formal way, and the last thing I did was I just added the chain rule down here at the bottom of our chart here. Down there it is, and that's the chain rule that we wrote on the last slide of the last video, and so there it is in our chart. So just to sort of say it one more time, what is the chain rule used for? It's for when you have one function plugged into another function, which again is very different than saying one function times another function. Okay, that's the product rule. If you've got that, if you've got x squared times sine of x, well, then use the product rule, because that's what it's there for. But if you have x squared plugged into the sine function, in other words, you'd have sine of x squared. Oh, well, now that's not a product. You're not multiplying sine times x squared, or sine of x times x squared. You're doing one function plugged into another, which is exactly the name of the game for the chain rule. I should say, why is it actually called the chain rule? It really should be called the composition rule, would be a more accurate description. But I believe the story is that it's called the chain rule because what does it actually look like, or what does the result look like down here in the chart? Well, it kind of actually just looks like, I mean, it's a little bit of a, well, it's what you'd think you could do. If you see something that looks like this, just do the derivative regardless of the fact that it's g of x in there and not just plain x, but then attach to it via a chain, which, sorry, that's a terrible chain link, that g prime, the derivative of g, is sort of attached to it. It's kind of like a trailer or something to the main ship, or to the main truck. You attach that onto the end with a chain. It is the dumbest, probably, math story. There's some reasonably good math stories about why things are the way they are. That's pretty much the lamest story to explain why something is called something. But anyway, I believe that is the true story as to why it's called that. So anyhow, so let's see it in action. Let's try this on some real problems and see what we can do. Again, I have to say, more than anything we've done all semester, you really need to practice this and try several of these. As always, feel free to pause these videos when I'm about to do a problem, and take 5 minutes to try it yourself before resuming the video. But these especially, the chain rule especially, there's just, again, not to freak you out, but there are many places where you could maybe go wrong, and so really, really important to do a whole bunch of these before you have to do one, on an exam, just to make sure it's, fluent, so to speak. All right, so there's our last look at the rule. I'll rewrite it immediately on the next slide, since we're going to use this like crazy in these examples. So, all right, so let's start. So again, just so we have in front of us, so the chain rule says we're trying to make our guy look like that. We're trying to make it look like one function, that's g, plugged into another function, that's f. And if we can do that, the derivative then is assembled by doing this. Okay, so we're going to still do the same things that we always did for the product rule and the quotient rule. We're going to write out what's f and what's g, and then we're going to take the derivatives of those things and figure out f prime and g prime, and then we're going to assemble our answer via this formula. Okay? So, all right, so let's start with our examples. So the first example that we might do is just, let's start sort of with hopefully an easy one to set up and an easy one to, compute. So let's maybe just start with something nice like sine of x squared. Okay, so now I should say, of course, on an exam, I'm not going to say, oh, this is the section of the exam where you should use the chain rule, right? So in addition to these other concerns that you might have, you also have to start thinking a little bit about Well, how do I know which rule I'm supposed to use? How do I know I'm not supposed to use the product rule here, or the quotient rule, or something else? So I'm going to try to help you with that too by saying, when we approach a problem and the question is, what is the derivative of this thing? You ask yourself, well, what is this thing? What form does this take? Well, hopefully the quotient, well, first of all, it's not in my chart, right? Nowhere in my chart do I see sine of x squared. So that's out. All right. So that means it's one of these rules. It could be a product rule or a quotient rule or a chain rule. Well, hopefully you can eliminate quotient rule right away, because I don't see any fraction. There's no division. So quotient rule is out. Product rule versus chain rule. Well, product rule would say you have one function times another function. Remember, I know it's tempting in math to say, oh, that's what you've got. You've got sine times x squared. But remember, sine, first of all, sine by itself, S-I-N, means nothing. So the sine is not a thing by itself. It's always sine of what? So it's not multiplication at all, because it's sine of x squared. Okay? If it was a product rule, it would look like this. It would say it's sine of x, times x squared, or something, kind of like that. Or maybe x squared sine of x is probably cleaner, right? This is the product rule. Why? Because that's one function and that's another function, and I'm multiplying them. So that's the product rule, okay? But that's not what I have here, right? I've got, hopefully, clearly, one function plugged into another function. This is screaming for chain rule. It looks exactly like this. It's one function, g, plugged into another function, f. So my goal to get us started before I can even write down the answer to what's the derivative is I should identify precisely what's f and what's g. So I'm going to do that first. Okay, so I should say who's playing the role of f and who's playing the role of g. And we've done several of these now, and hopefully this one's not too hard. And if you look at it and you say, okay, well, what's what here? Again, using the tips that I gave you in the last video, you might say to yourself, well, g should be the thing that's happening first. Well, in my problem here, sine of x squared, if I was to plug in x equals 4, you would first do 4 squared and get 16, and then you would do sine of 16. So x squared is what happens first, and so that should be g. Or again, using our other tip from the last video, g of x is often what's inside of the parentheses. And look, in this case, perfect, right? That's exactly what g of x is. It's what's inside the parentheses. Okay, or at least I think so, right? I shouldn't speak so confidently. I'm not sure that this is right yet, but I'm going with it. I'm thinking, right, okay, so g of x is x squared, because I think that that's sort of the first thing that I do, or that's what's on the inside, or whatever logic you're using. And then I say, okay, well, what am I doing to g, right? What operation? What, namely, what's f? Well, what's happening to x squared? It's being sent, I'm going to take the sine of it. So what function is it being sent into? Well, it's being sent into the sine function, sine of x. Okay, so, sorry, I leave myself space there, but that's f, and that's g. And then, again, when we're still getting good at this, I should check. Is that right? Did I do that correctly? And you can always check it very easily just by asking yourself, okay, if I think that this is the f and the g that are correct, then what should I be able to do? I should be able to say, so if I take g and plug it in to f for x, I should get what I started with. So now I'm going to take g, and if I was to plug that into x there, would I get this? And hopefully the answer you can see is yes, I do. So that's right. All right? So I've made a correct choice of f and g, I think. And so, wonderful. That's half of the battle, really. I mean, in many ways, and that may even be the hardest part of these problems. So, so we've got the setup. So what is it that I've sort of certified right now is that indeed I have this. My guy here looks just like this for this choice of f and this choice of g. Okay? So that means I can use this rule, right? The rules, again, you can only use a rule if you sort of have it set up correctly. Well, I have it set up correctly, so I'm going to now use the rule, right? So all right, now in order to use the rule, to get the answer, I'm going to need to know G prime, and I'm going to need to know F prime. So why don't I do those, right? So this should look familiar, right? Sorry, I don't know why the semicolon is bothering me, that it's, that it's there. Okay. All right, so, well, just like in the product rule and the quotient rule, we sort of hopefully got in the habit of saying, as soon as you know what F and G are, it's not a bad idea to go ahead and write down the derivatives of each of those guys. And hopefully these are in the chart, or they're almost in the chart. And these two guys are, right? The derivative of sine is cosine, that's in the chart. And the derivative of x squared we've done so many times now, right? It's 2x. All right, so I've got my four pieces down here, and actually I only need 3 of them. But now I'm ready to fill in the result of what is the chain rule. What does the chain rule say? I've gotten my setup correctly, and so now I'm going to say, all right, so now let's cash in on this and say, now I'm ready to tell you what's the derivative. Right, I'm going to use the rule now. So the derivative is, well, it's this. It's what do we see on the right here. Now I'm just going to caution you. You have to be very careful, and I apologize for being negative in advance. But having taught this class dozens of times, there are students that even by the end of having done 1,000,000 of these are still writing this incorrectly. So I don't know much more to caution you except to say, this is not f prime times g of x, okay? It isn't. If it was, I would have written that and not that. So don't do this, and sorry, but this will always be an option on a multiple choice situation. Don't just say, oh, so it's cosine of x times x squared, because that's f prime and that's g. So it's cosine of x times x squared. Okay. No, this is not just f prime times g. It's not just these two things multiplied. Okay, so let me erase what it isn't so you can see it again. What is it then? Okay, so I've gone to all this trouble to say what is it not? Well, what is it then? So there's a lot of ways to sort of think about this. You can either try to sort of do this all at once, or you could do it in steps. I don't know what's better for you, so I'll try it sort of both ways. What is this? Okay, g prime, that's pretty easy, right? That's just going to be 2x. So I'm not worried about that. But what's this front piece? What's this first thing? Well, if you want to do it sort of in steps, you could say, all right, let me do it in steps. So I said, okay, that's f prime. I know what g is. G of x is x squared. So let me at least just write that. And I know what g prime is. That's an easy one. That's just 2x. Okay, but then I could say to myself, but wait a minute. I know what f prime of x is. Look, f prime of x is right here. It's cosine of x. But this isn't f prime of x, is it? It's f prime, but with x squared plugged in, which means I should put an x squared right there. Okay? So I think this front piece, after, a little bit of debate here, I'm going to erase this because it's in my way, should be cosine of x squared, and then times 2x. And that's the answer. Okay? So, it takes a little bit of practice, I think, to sort of feel the flow, so to speak, of being confident that, you actually know all these steps and you're not going to sort of botch something. And that's totally reasonable that you're going to need to do a bunch of these before you feel good. Oh, let me just say, if you wanted to do this all in one step to get to the end, to get to the cosine, right, the other way of saying, what is this, is you could say, and I see some students do this sometimes, when they actually write out their 4 pieces over here on the left, they actually say, okay, and I know I'm going to take this and plug it in there. And that's perfect. That's fine. You could say that, because indeed, that's exactly what this is. So this front piece is always just going to be whatever this is, jammed into whatever x's you have down here in the f prime line. That's fine too. And then maybe you don't need to say it in 2 steps. You could do it all at once. If that makes you feel better, then do it that way. I'll probably more so do it this way, just to kind of be as slow as possible to make sure I'm careful. Okay, but in either case, you get that as your answer. All right, so that's one example. And that's a pretty easy example, I'll be honest, and easy in the sense that these were kind of not too tough to pick, right? Picking the correct F and G were pretty easy, I think. And then assembling this was also not too bad. And there was no simplifying at the end. Okay, so, because there's nothing I can do with this. Okay, and again, just as a point of clarification, I can't multiply that and say that that's 2x cubed. Again, I know math is sort of notationally maybe a little annoying, right? But I can't say that, right? Because this x squared is part of the cosine. It's cosine of x squared. Whereas this 2x is just regular old 2x. He's just sitting out here, okay? So just don't get confused. And it's perfectly fine to just leave your answer like that. Okay, so I think I have space here, so let me put one more example in right here, where maybe there's a little bit of simplifying at the end of the problem for us to do. So let's try maybe one that has an ln in it. So maybe I'll say ln of, maybe I'll try to make it a little more interesting, maybe x to the negative 2 power, which is the same thing as 1 over x squared, right? So I could have said ln of 1 over x squared instead if I wanted to. Okay, so I want to know what is that, right? What is the what's the derivative of this? Again, I'm going to try to be you guys for a minute and say, all right, I approach this problem and I ask myself, what is this, or what rule do I need? And again, the easiest type of derivative is one that's in my chart. Well, I don't see ln of x to the negative 2 anywhere in my chart, do I? So that's out. It's not that easy, unfortunately. And it's not just, you know, a number times a function, and it's not 2 functions added or subtracted with each other. I don't see a division sign, so it's not a quotient. So, you know, I quite often am sort of left with these 2 options. Is it a product or is it a chain? Well, I can just sort of ask myself, I think, one more question. Is this something times another thing, or is this something plugged into another thing? And hopefully you kind of can immediately convince yourself that it looks like it's something plugged into. Because again, just like sine by itself doesn't have any meaning, ln by itself doesn't have any meaning either. It's the ln of x to the negative 2. Okay, so hopefully you have your little talk with yourself there and convince yourself that this looks like I'm going to use the chain rule once again. Okay. Again, it's helpful if you kind of identify for yourself, what rule am I using? And it's helpful for me too. So this is going to be a chain rule, and so let's see if we can get it set up. So for the chain rule, I'm going to write down my usuals. I'm going to say what's f and what's g. And again, I'm trying to always mimic this, right? I'm trying to get it to be g plugged into f, or first thing I do is g, and then the next thing I do is I would plug it into the f of x function. So in this case, what do I have? Well, I've got x to the negative 2 power. That's something. And then I'm going to plug it in, and then I'm going to do the ln of that, right, the natural log of that. So kind of similar to the first one. Hopefully it jumps out at you. That the first thing I would do would be x to the negative 2. Or I could say, what's inside the parentheses? Also, x to the negative 2. So hopefully all signs are pointing to that as the g of x, because that is the inside function. Again, right, that's the first thing I would do. That's right there. Okay, and then what is happening to it after that? That's f. Okay, so in other words, what am I then doing to it next? Well, I'm going to do the ln of whatever g is, right? I'm going to do g plugged into the ln of x function. Okay, so and again, I should just double check. Do I have this right? Is it true that what I'm looking at is G with that plugged into the F. Yeah, it is. Okay, so I think I've got the correct setup up here. All right, so I'm going to now go ahead and use the chain rule and see what I get. So for the chain rule, I'm going to need to know the derivative of each piece, because I'm going to need those in a minute. And these are both nice and easy because they're in my chart. So ln of x is in my chart, and the derivative of ln is 1 over x. And x to the negative 2, that's in my chart also. That's the third rule in the chart here, which says if you have x to any power, that's the derivative. Okay, so I bring the coefficient down in front, and then I subtract 1 from the coefficient. I'm sorry, I bring the power, the exponent, down in front, and then I subtract 1. Okay, so let me do that. So I would bring the negative 2 down in front, and then I subtract 1. Well, if I take 1 away, that would bring me down to negative 3. Okay, so that's G prime. All right, so I'm ready to assemble. I'm ready to assemble my answer, which is over here. And I'm going to choose to do it in a two-step format. So let's see. So here's my derivative now. I'm actually going to do this. So the derivative of this guy I started with is via the chain rule, the following. So I want to write this stuff down. So I'm going to do it in steps. And I'll say, all right, it's f prime with g plugged in. Well, I know what g is. G is x to the negative 2. So I'm going to just sort of write it that way. And then times g prime. Oh, g prime, that's easy. That's over there. So that's times negative 2x to the negative 3. And then I come back and I say, well, wait a minute. I know what f prime of x is. F prime of x is 1 over x. So f prime of this thing means I should put that, which is g, plug that in for x. Okay, so as funny as this kind of maybe looks, f prime of whatever is 1 over whatever, right? That's what that basically says. So I have f prime of x to the negative 2. So I should get 1 over x to the negative 2. And then I still have times this guy over here. Okay, I know that always looks a little bit, I don't know. It's tempting, again, I know it's very tempting to just write 1 over x and then times x to the negative 2. But again, that's not what this is. This is saying take your g and actually plug it into your f prime. So that's what I did, isn't it? I took g and I plugged it in for x in f prime. And I got 1 over g, or namely 1 over x to the negative 2. Oh, there it is. Okay, now in this problem I can actually simplify a little bit here because I just actually have a fraction here, right? This is just a big fraction. So on the top of the fraction, so let's say here, I have what? Negative 2, and I have x to the negative 3. That's on the top. And on the bottom, I have x to the negative 2. Well, negative exponents, remember, how do I deal with negative exponents? They're the same as the positive versions if you move them. So in other words, x to the negative 3 on the top is the same as x to the positive 3 on the bottom. And x to the negative 2 on the bottom is the same as x to the positive 2 on the top. So that's actually the same thing. But now hopefully you can see, right? I can cancel x squared with 2 of those, leaving me with just 1. So actually, as simple as it looks, negative 2 over x. That is the answer to what's the derivative of this guy. Okay, so that's so there's another example of the chain rule. Okay, so Maybe let me do just one more that's at least a slightly different type, so that we don't always get in the habit of thinking that it's always going to look just like that, like those two guys. And instead, let me do one where maybe the inside function isn't just a power of x or just a polynomial type thing, but maybe that's instead the outside function. So, okay, so what might I have here? I might have something like e to the x plus cosine cubed. Okay, so I approach this problem and I ask myself, what rule do I need? Again, I do a quick discussion, and I think that hopefully we're getting faster with these, right? This kind of does still look like one function plugged into another, right? I've sort of got e to the x. Now I've got e to the x plus cosine, so that's actually sort of two functions, I guess, right, added together. So I have a little bit of, I'm going to be slightly concerned that that's not just cosine of x or just e to the x. Okay, so I'm thinking about that, and I have some thoughts about that. But ultimately, that is then going to be cubed, right? That's this whole thing is made up of saying, I'm going to do that stuff in the parentheses first, and then I'm going to cube it at the end. So again, if I was plugging in x equals 0, I would do e to the 0 plus cosine of 0, and I'd hit enter on my calculator. And then I would cube the result of that. Okay, so I'm still sort of thinking this sounds, hopefully, and looks to you like it's still a chain rule. It still looks like something plugged into something else. Okay, so I'm still going to proceed by using the chain rule here. And again, I'll write it down one more time so that we have it in front of us. So I want to try to say one guy plugged into another, and then I'm going to get that times that as my answer. Okay, so all right, so as always, step one is I have to make it look like that. So I have to identify who's playing the role of F and who's playing the role of G. And I have to think a little bit about this one, I guess. But I think about my strategies again, right? My strategy is that what's G? G is what I do first, or G is what's in the inside of the parentheses, or whatever. And then F is what do you do second, or F is what do you do next, or what do you do last. So I'm looking at this guy and I'm saying, okay, again, if I'm going to actually evaluate this, the first thing I would do is the stuff in the parentheses. So I'm going to try it, right? I'm going to say, so how about I pick e to the x? And let's say I just stopped there and said, I think that's it. Because that is, technically, that is what you would do first. I would do e to the x. Now, when I say, okay, well then what do I do to e to the x? Well, I cube it, that's true. But I kind of am a little bit nervous because what about that cosine? I haven't used it. And again, I'm going to hopefully try to instill in you that you should always use everything in your first pass through a derivative. So when I'm trying to do the derivative of whoever, I should always say, well, the first rule I write down, you should really use everything. For the simple reason that if you leave something out, you're probably never going to come back to it. Or if you do, you're going to probably make up some way which is not a legal way, and you're just going to sort of throw it in somewhere. So that's probably not good. So again, just try to think about if you stopped yourself here and said, I think that's it for G, and you said, well, what do I do to e to the x? I cube it. That's true. But I lost the cosine. So I'm going to say, all right, you know what? Maybe I can actually say that's the inside function. Because it's not a crazy thing to say, right? That is actually what's inside the parentheses, isn't it? Right? It's actually all of that. Now I know that's two functions, but that's all right. I'm going to roll with it and say let's see what happens. Now what is it that I do to G in order to do this? Well, the thing I do next is I would cube it. So it must be that I'm sending it into the x cubed function. And again, I check myself one last time. Is it true that what I've written down up top is G plugged in for x in my F? Yes, it is. Okay, so I think I got the right F and the right G for the chain rule. All right, so I've got the setup piece correct, so I'm ready to do my answer. All right, but in order to do my answer, I need to know the derivative of each of these characters, and these are both, neither one of these is too hard. The derivative of x cubed is 3x squared. Now the derivative of g, technically I have to use what, the addition rule, because I have one function plus another function. But that's okay, right? I have a rule for that that says if you want to do this, just do the derivative of each piece and add. So in reality, I'm not too worried about this. The derivative of e to the x is e to the x, and then the derivative of cosine is negative sine. So I would get plus negative sine, or just minus sine, right? Plus negative is the same thing as minus. So that's g prime. Okay, now if I had like a product in here, like if that was multiplication instead of addition, I would still actually do this. It's just that to do this step, I would have needed the product rule. Okay, so what? I could have done the product rule there if I needed to. It's extra work, but it's not a deal breaker. Okay, so I think I've got my pieces in place, so I'm ready to assemble my answer. So I'm gonna, sorry, I have to sort of do it this way. So I'm gonna do the derivative now. So I've got it all set up, and so my answer is that. So let's write down what is that. So let's see, so I'll do it in steps again. So it's f prime, but with g plugged in. So g is actually all of that from over here. And then times g prime. Okay, that's easy, times that. So I'm going to put that in parentheses. So times that. Okay, but now I say to myself, but wait a minute, f prime, I know what that is. F prime of x is 3x squared. So f prime of this thing, that should be what goes in for x. So as awful as this looks, this is actually 3x, which is that, or in other words, or that's what I'm plugging in for x, squared times this g prime piece that's still sitting out here. And that's the answer. And there's no simplifying this either. I mean, you can't really, there's not a lot of things you can simplify. If you've got a fraction, you can maybe do some canceling, but I don't have a fraction here. So there isn't anything I can really say about this, and just leave it alone. It's kind of a mess anyway. So, okay, so that's one, so that's another example of the chain rule. I guess the only other type aside from these that you might have is if you have sort of like a function, like a trig function plugged into another trig function. You could do something like that. Maybe I should just do one more while we're all together here. Maybe I'll try to do this a little more quickly. So you could have something like, oh, I don't know, ln of sine of x, or something like that. Okay, so let's see. So I'm looking to say, again, what rule do I need? And again, it's not multiplication, right? It's not ln of x times sine of x. That would be the product rule. But it's not, it's right, it's one function plugged into another. Okay, so this sounds like the chain rule. So again, I'm thinking about, I'm trying to make this look like that, so that when I do the chain rule, or so that I can use the chain rule, and my answer would be f prime with g plugged in times g prime. Okay, so let me pick my f and g here, and again, stop the video right now and try it yourself. So I'm going to ask myself again for the what feels like the millionth time today, who am I plugging into whom? So what do I have plugged into what? Again, g of x is what do I do first, or what's on the inside. Hopefully it's pretty clear that the first thing I would do is I would do sine of x, and then I'm plugging that into ln of x. Okay, so again, right, the setup here is that this, the thing I started with is indeed my choice of g plugged into x in my choice of f. Yes, that's what I've got. Okay, so that's exactly what that says. All right, so I've got my setup validated, verified, so I'm ready to go over to my answer. But to know my answer, I'm going to need to know the derivative of each of these guys, but they're both in my chart. So that's pretty simple. And I'm ready to assemble my answer. So my derivative then is just, what do I get over here? So let's see. So I got f prime with g plugged in times g prime, that's easy, times cosine. Okay, and then, but I say to myself, but wait a minute, f prime, that's over here. That's f prime of x is 1 over x. So f prime with sine plugged in just says, oh, so take sine and plug it in. So I just get 1 over sine times cosine. Whenever you have sort of the time stuff over here, right, this is always, if you end up with a fraction, that's always on top, right? So cosine is on the top, so don't get confused and somehow think it's on the bottom, right? The times g of x that's sitting out here on the right, that's, you know, on the top, so to speak, or on the ground floor. It's not in the basement. Okay, so actually you just get, what, 1 over sine of x times cosine? Or, of course, you could say that's just cosine of x over sine of x, which actually is just cotangent. Okay, so either of these are fine to write down as your answer. Cosine of x over sine of x, or just the cotangent, which actually that's exactly what the cosine over the sine is the same as is cotangent. So either way, that's fine. Okay, so I think this gives you a pretty good sense of hopefully how to use the chain rule in some basic ways. And by basic, I mean, you know, where you've got just a single round, so to speak, to do. So in the next video, I'll do some more complicated examples of these, where you maybe have the chain rule involved with the product rule or the quotient rule, which isn't really harder. It isn't. It's just that they get very long. It starts to get to the point where, you know, a problem is going to take you 10 minutes just because there's so much stuff. So it's kind of, you know, it's neat, I guess, a little bit to see how to see how bad they can be, but it really does start to lose some the practicality of when the hell would I ever have to do this. So anyway, so but these, what did I do? 4 of them here. These are good. These are reasonable to say, okay, I maybe have ln of sine of x. That could model something, some sort of motion or something like that. So these are reasonable types of things. And again, these are a nice introduction to the chain rule, which is good, which I'd have to say of all the rules is the most important one, just in sort of math in general, and is definitely one that for us, what are we doing after this? So we have sort of maxed out on derivative rules and derivative strategies. So the rest of the semester is all applications of why do I care about the derivative? And the chain rule is by far the most important rule going forward for helping us understand modeling and sort of physics and things like that, which is what we'll spend most of the rest of the course doing. So anyway, all right, so good luck with these problems, and again, do please try them and try all of the homework problems and really, really give it a fair shot. I think that, again, for the first time of the semester, this really is something that if you're just sort of watching problems be done for you, it's easy to be like, oh, okay, I see how these go. But then when you sit down to do one on your own without the answer in front of you, can be very scary, you know, if it's the first time you're trying it. So, so try them now and try the homework so that you're not caught off guard and surprised on the exam. So, okay, so good luck with these.